So hello everyone, my name is Shivam Pandey and you're watching on Uncover and Discover YouTube channel. And in the last lecture, we did the important concepts of data structure, which were based on stack queue and various implementations based on these structures. And for now, we are discussing the topic stack in detail. So basically, this topic stack comes into your unit number second of your AKTU, uh, uh, AKTU like your syllabus of SEM 4th. So basically, for your stack, you are going to study different principles of stack and terminologies used in stack. You are also going to find and discover the ways how we can implement and write codes in the language C to make a new stack and to perform various applications like addition, deletion, pop, push, and various other things you can do in stack. So now let us begin with what is stack. So basically, stack is a linear data structure that follows LIFO principle. So you might be thinking that from the definition, it is very clear that stack is a linear data structure. So like various data structures like string, integer, and various other more, it is also a data structure which is used to store some values in C language or any other language you can use it. So, what is the need of a new data structure? So, basically, the data structure we have till now, the basic data structures are string, integer, and boolean, and many more. But this structure is unique, and it what makes it different from other things or other data structures are that it follows a principle of LIFO, which is last in first out. For example, if there are three persons in a row, or for just an example, suppose that you are in a wedding and you are going to eat from a plate, and you're going to and you're going to pick that plate from a table. So what basically happens in a wedding or something function like that, they keep a stack of plates. So basically, what the stack means that first of all, imagine that when a person is setting up that whole stack of plates, then he might have put the first plate on the table first, then second on top of it, then third on top of it, and then fourth on top of it, and then the whole stack is maintained like that. So, for example, if you are going to take one plate from the stack, then what you are going to do is that you are going to pick up the topmost plate of the stack. Uh, like you are not going to do the thing that you are removing the top elements and you are taking the plate from the bottom. This usually don't happens, but in some cases, some people do it. But we are not taking that case here. We are only taking the case that a person goes to a stack of plates and takes out the topmost plate from the stack of the plates. So similarly, here in the stack itself, it is a last in first of principle based data structure, which allows users to take the first to insert the element from the bottom, but only the topmost element will be popped or deleted from the data structure. So this is the basic idea behind what is stack and how does it function. You might be getting some basic idea of what is stack, and I can bet you that after completion of this lecture you will be into and you will be getting more about stack, and you will feel much confidence in in this data structure. Yeah, so here we have it is written the LIFO principle. It means that the last element added to the stack is the first one to be removed. The same thing I explained you in detail, that how the stack works and how elements are removed and pushed into the stack. Pop also happens from top. Yeah, so it basically the same point which I explained you. So here we have given two basic technologies of stacks. The first one is top and the second one is size. So top. So what is top? Top is the position of most recently inserted element. Push and pop are always performed at top. So basically, a top is a kind of pointer, but here it is not here it is not dynamic, but it is static, and top maintains the topmost element of the stack, uh, by which we can perform the pop operation from that point. For example, if we have three elements 10, 20, and 30, and 10 is inserted onto the first place, then the 10 will be the topmost element of the stack. And when any pop operation gets performed on the stack, then 10 will be removed from the stack, and the other elements 20 and 30 will remain into the stack, and nothing operation or nothing changes would be done to these two elements. Now, what is size? Size refers to the current number of elements. For example, if we have three elements 10, 20, 30, then the size of your stack would be 3. This means that you have three elements into your stack, and yeah, so we have given types of stack. So basically, we have two types of stack that I already described you in my introduction in the last video. The types of stacks are of two types. The first one is fixed size stack, and the second one is a dynamic size stack. So what is the fixed size stack? The fixed size stack is predefined capacity. Once full, no more elements can be added. Stack empty, try to remove element because of underflow. Typically implemented using array. So we implement the fixed size stack using the array data structure, which is most commonly used in the coding languages to store a set of sequential data in the data structure. Also, we have predefined capacity. Yeah, so we have to declare the capacity and the size of the array of the stack beforehand, so that the compiler reserves that space for that stack, and when any element is inserted into it, then it can hold that place to store them. And basically, if you do not use or complete that capacity or use fully that capacity, then the remaining part of the stack gets wasted and it is of no use. As we have declared the size earlier, so we do not have option to decrease or increase the size. We can only do it in the case when we automatically increase the size in the topmost or where we have declared the array. Now, second type of stack that we can see is dynamic size stack. So it grow and shrink automatically as needed. The stack is full, capacity expanded to allow more elements. Elements are removed, memory users can shrink as well. Implemented using linked list dynamic array. Yeah. So what dynamic size stack is? Basically, you know what the word dynamic means, right? So dynamic is the basic idea where the size is not predefined for any data elements. For example, if we have linked list or if we have linked list also, then it is a dynamic kind of data structure where we do not declare the size of the data structure beforehand. We declare we get the size in the runtime. So it is quite better, and it is more efficient for a very large element of data. Or you can say that we only use in the places where we need to have or adjust a large amount of data in companies or any other place. So basically, dynamic size stack is a stack where we can the where the element addition or deletion can be performed in the runtime, and no more pre-declaration of the size is required beforehand. And to implement it, you can use linked list as I told you. Yeah, so basically linked list, you all know that it grows and shrinks automatically, and dynamic array can also be used. Basically, you will be most of the cases you will be getting English to implement the dynamic size stack, and the dynamic array is used a little bit lesser, but yeah, you can use it too to make your things. Stack implementation using linguists are resizable. Yeah, so it is correct and it is true. So yeah, so now we are going to learn about the common operations on stack. The first operation is push, second is pop, third top, fourth is empty, and fifth one is size. So you already know about the size. The size gives you the exact number of elements in your stack. Now we learn about these four elements or operations one by one. So basically, what push is? So when you hear the word push, you get some idea where we are pushing or adding something into a data structure, right? So in the push operation, we add one element in the stack by using the LIFO principle. So, for example, if we have three elements in the stack beforehand, like 1, 2, 3, and we are going to push four into it. So basically, what happens is that 1, 2, 3 will remain into its position at the first. Then, if the addition of four has to be done into the stack, then 1, 2, 3. So one will shift to one more place higher, or it will move towards the topmost element, and the three element would also move towards one more upper side, and one place will be vacant for four to be stored. So if we make the indexing of the stack, uh, at the beginning, the indexing will start from 0, 1, and 2. So at the 0th index, 1 will be stored, at the 1st index, 2 will be stored, and so on. And if we change the indexing, then what happens is that the 0th index would move to one more place above. That means that we have at the 0th place we have one, at one we have two, two we have three, and the third place or the third index we get four. So that's how we make a stack of four elements by doing a push operation. Now we have pop operation. So pop operation, pop means that pop happens to delete something from a stack or any other data operation. So basically, what a pop does is that it removes an element from the stack. For example, same stack we have four elements, 1, 2, 3, 4, and if we are doing the pop operation, then we see that which elements was inserted first into the stack. So basically, to get the pop operation, we basically look for the topmost element and we remove the topmost element from the stack to get the pop operation done. So here in our case, we have the topmost element as one, and if we are doing a pop operation, then we have to delete the one element from the stack or the 0th position index element from the stack. Yeah, so top returns the topmost element of the stack. In our case, it is one. For the example we have taken, is empty. Is empty basically returns you a value of 0 or 1 or true or false or whatever you set it in your function. So it tells you about that whether your stack is empty or not. For example, if your stack has no elements or your stack is empty, then it will return you one, or it can also return you true based on your what you have coded and what you have said like the data structure. You have used boolean or a string. So it depends upon what you have coded, and is empty returns you the whether the stack is empty or not. Simple. So what are the applications of stack? So the applications are simple and you can just look upon these. The first one is function, recursion, undo, redo, syntax parsing, and memory management. So let's see upon the first function. So a function, it return address to resume execution. Yeah, so what you are showing into stack is that the indexing and the storage and the pop addition becomes very easy while we use stack. It is so because we are only using one principal LIFO, and we are storing the elements based on this operation only, this principle only. We are not using any other principle or any other complex situations to do things. We are only minimizing or only keeping ourselves limited to only a simple principle, which is based on last in first out. The second application is recursion. Yeah, so you will get numericals and questions about recursion in the further unit. So recursion is very basic, and you can do codes like factorial, and you can do operations like factorial and various other numericals you can solve using recursion. Yeah. So third one is undo redo that executes in Photoshop and text editors. Also, this is used in some parts where you make mechanical models and some applications in your web designing or anything else. The fourth one is parsing, validate syntax in programming and formal languages. So, in at this level in your BTech second year, I don't think so that you have to know much about this syntax parsing, as this is of future, and you will get these things into your third or fourth year, or you will come across what parsing does exactly in your programming languages in your future, but it is not important as of now. What are the advantages of using stacks? The first is simplicity. The second one is efficiency, LIFO order. So the one thing I would say about stack is that it is very easy to use and easy to implement and easy to code as well. I would say. The For example, if you get any question of stack in your exam, you will feel much confident and much more confident in your exams by seeing these questions. And if you get a chance or option to solve question between queue and stack, I would suggest that you solve a stack question, as it would more be good uh, to s- to score good number in your examinations. Right. So let us now move on towards implementation of stack. So yeah, so you can implement stack using using array and linked list, as I have told you before also. And just a second, I had to do an urgent message. So yeah, sorry. So yeah, declaration of stack using array, and yeah, so you here we are starting the code implementation and how to use the exact C language to write some code and make you write something. Yeah, so declaration of stack using array. Integer array store numbers, variable capacity to represent max size of stack, variable top to track the index of the element, top equals to -1 indicate the empty stack. Yeah. So if basically if the top is -1, this means that your stack is empty, and integer is only stored in stack. I think so. If you are storing some strings, that is acceptable, but yeah, it depends upon your choice what you want to do. And yeah, but in C language the you can only store the integer elements into the array. Variable capacity to store represent max size of stack. Yeah, for the push operation. Now let us see how we will get the code. Yeah, for int max size, you have declared your hashtag include studio.h in your C language. You have made your max size equal to 8. That the maximum element you are going to store in your data structure is 8. And upon moving, we can see the stack has 8 elements. Top equal to -1 means that in the beginning your stack is empty, and when you do +1 here, then the top becomes 0, which means that you are storing the element at the 0th index. Or it also means that you have some element into your stack, and your stack is not empty right now. Yeah. So we have got the operation of int is full. So int basically means that you are going to get the result into an integer only, and you are not going to get a string or anything like that. So is full basically returns you that whether your stack is full or not. Yeah, for example, if top is equal to max size, or if the topmost element in your stack is the same size as your max size, then it means that your stack is full and nothing more operations of push would be can be operated on your stack because it is full. And you know that if anything is full, then you can't add something into it. Yeah, right. If something is empty, then you can add something. Or if something is full, then you can perform one pop operation to delete something, and then you can perform pop or push to add elements. So yeah, so here we have one function of push, which int push in data. So it basically we have a perimeter of in data. What in data is doing that it is adding element, or we are passing a perimeter of data which we are going to push into the stack. So in the int push function, we are declaring if is full. We are firstly checking that the stack is full or not. If top equals to top plus one, or it means that the topmost element is zero or one. Stack top is equal to data, which means that stack top is equal to data. Yeah, right. Else printf. Yeah, so basically what we are doing that if firstly we are checking that the stack is full or not, and if is it not and if it's not full, and what we are doing that we are increasing the pointer from top minus one to top plus one, which means that we are adding one into the top element. So the index of top becomes zero here if it's empty right now in the beginning, and it's obviously true that in the beginning it would be empty, and it's not full here. So we will get the index of zero, and stack top means that here you are storing the index of the element of stack. So stack zero, which means the zeroth index of stack would have your data, and if the stack is not full, and if the stack is full, then you return in the else statement printf return stack full. Yeah, so we are now using this two operation push and is full to implement a basic stack in C language. So yeah, int main, int I, push 44, push 10, push 62, push 123, push 15. So basically, if I can do some, if I can take my marker and I can explain you things, it would be better. I think so. It's working. No, it's not working. Sorry. Yeah. If you can, mm, I think so. Something is wrong. Yeah. Yeah, I got it. Yeah, it's correct. Working. Yeah, so first of all, we make one stack like this, and we are firstly inserting 44. 44 will get an index of 0 in the beginning, right? And when we insert 10, then what happens is that uh, here we get two elements, and the indexing becomes 0, 0, sorry, 0, and 1. So 44 comes here and 10 comes here. Yeah, so basically, if we are pushing elements like 62 also, then 44 will become the topmost element, 10 the second topmost, and 62 at the last, then 123, and then followed by 15 and what you all can insert. Right. So I explained you with an example and code to how to do operations in the stack. Now we are getting the pop operation. Removes an item from the stack. It the items are popped in a reverse order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. If the stack is empty in the beginning, then you know that there's nothing is there in the stack and it is an underflow condition or the stack is empty. Then you can perform push operation into it, but you can't perform pop operation because the stack is empty. Nothing is there in the stack, and if nothing is there into the stack, you cannot remove something. If, for example, if you are suppose taking an example of a Maggie packet of 12 packets inside a packet of 12 Maggie packets inside it, then if the packet is empty or there is no Maggie packet inside the big packet of the Maggie, then you know what, then you can't take one Maggie from it. Yeah, it's true that if something is empty, you cannot take something from it. So before uh, before like before popping it, you have to firstly check that whether it is empty or not. And if it is not empty, then you can basically perform your operations. And if it's empty, then you can't. Yeah, so we are writing the functions of is empty. If is empty, it will return and it will not perform any operation and it will return one or zero. So if top equals to minus one, so basically if the top is at the shell at the minus one position, we have firstly initialize the top pointer as minus one, which means that the element is not inserted into the stack, and the topmost element is of minus one. So if top equals to minus one, then return one, else return zero in pop. In pop. So what pop operation does is that it removes the element from the stack. So what we are doing is there we are firstly checking that whether the stack is empty or not. So we have made one condition of if is empty, and you are calling the is empty function from the top. So is empty, you have discovered and known that what is empty is doing. And if the stack is empty, then it would return the stack is empty, return minus one. And if the stack is not empty, then you can perform a pop operation, as you all know why. And the pop operation would be done in a manner that it not that the other elements not get hampered, or the whole data is not removed from the stack. Only the pop operation does perform on the topmost element. So we make uh, in, another integer element data which stores the value of the topmost element of the stack, and we do perform operation of top equal to top minus one, which decreases the top index value by minus one, and we decrease the value of top, and then we return data. So it stores the topmost, and by this way, we remove the topmost element from the stack, and we return that we have performed the push operation, and and the topmost data from the stack is deleted from the stack. Now we are seeing English application of stack. I would say that it is not so important according to your AKTU syllabus, but it might uh, be asked in your exams. I would not say that you leave it, but I would also say that you do it on your own, because these things are limited to, I think, the array only, because at this level using Linglist for implementing stack is not very much fruitful. You basically brush up your skills by using array only in the beginning, and if you master this, then you can basically switch on to like English and dynamic array. Yeah, so in this lecture, we are keeping only these simple operation functions, and in the upcoming lecture, I would be taking these codes, and we would directly be switching onto VS Code to write and implement these codes by which we can get a better knowledge of these structures. And in the also in the upcoming lecture, I would be taking the classes on Q. So we will get the whole concept of Q in just 1 or 2 lectures because it is very easy. And yeah, this question of infix to postfix conversion and postfix to infix conversion is very common into your exams, and this usually comes into a 7 marker question. So I would also taking a lecture on this. So for now, the class is over, and thank you.